Hi guys, and welcome to this video on matrix multiplication. My name's Dan from Maffs. Thank you very much for watching. Hopefully the video is going to be useful. Before I get into all of the learning, can you do me a small favor? And that's clicking a button. That's on YouTube. If you can subscribe to my YouTube channel, I really would appreciate it. Just lets me know that actually people are watching. And if you can follow me on TikTok and all those other wonderful places on social media, I would be deeply, deeply grateful as well. Just basically knows that I'm not sitting in a room talking to myself, which I feel like I'm doing most of the time. Now, what are my learning objectives from this lesson? Understand how to perform multiplication of matrices. Know the rules to be able to perform multiplication of matrices, and there are actually rules. And know that in general, matrix multiplication is not commutative. That means AB is not equal to BA. Now, what I mean by that is basically in sort of the real world, if I was to do 2 times 3, it would be 6, wouldn't it? And what would 3 times 2 be? It would be 6. Now, what we've noticed here is we've just swapped the order of the numbers, but actually the values of my answers came out exactly the same. Okay, so that suggests then that matrices, you can't do that, or generally speaking, it's not going to be the same. Okay. Now, in the past lesson, if you notice, we've got the idea here that we can define a matrix and we can put it into our memory and we can call it letters and all sorts of interesting stuff. And if you don't remember, go to mathsguru.com, sign up, absolutely free to sign up, and you can watch the videos, download notes, etc, etc, etc. Now, when we have a 2a or a 3a or a 5a or a 1.5a, then we know that what we're really doing is multiplying every element of a matrix by 2. So that 57, when it doubled, became 114. 63 doubled, 126. 48 doubled, 96, and so it goes on. So scalar multiplication is okay, but that's not what we're going to be doing in this particular video. Now, can we see the odd one out here? And there's lots of things here that take place. So first things first, if we look at this line here, we see that we've got 2 matrices multiplied together and a matrix answer comes out, right? So it has been possible to multiply well, let's talk about orders. We know about the orders of matrices. That one there is a 2 by 2, and we have been able to multiply it by a 2 by 1. And how do I know we've been able to do it? Because we've got there a, what have we got there? We've got a matrix answer, and we know it's a matrix because of the square brackets. Now, it's interesting, isn't it? Because it looks like when I multiply those two together, I do get an answer. But it's not a matrix. I've just got a number 2 there. And if we look closely here, there's something actually missing in the middle. And that is the multiplication sign. So your calculator has done something weird with this. It feels it can do something with it, but it's come out with a non-matrix answer. So actually, that there is a mistake. That's really the odd one out. Then we've got these 2 here. We've got error, dimension error. Now that's what comes out on the TI Inspire. If you're using a ClassPad, I'm sure it'll come out with something else. But let's just see why. Let's look at the order of this one here. Let's look at the order of those 2 matrices. So what have I got there? I've got a 2 by 1 followed by a 2 by 2. And for some reason, there's something about this that is telling the calculator that's not going to be possible. I can't multiply them together. All right. What about these ones here then? Also can't be multiplied together. So what have I got? I've got a 2 by 3 and a 2 by 1. Now what could it be? Just by looking at these, believe it or not, I can tell automatically that these will never be able to be multiplied together. Coming up. Now, as I say, the order of a matrix is really, really important. If you remember, the order is about the number of rows followed by the number of columns. And we write that as a 3 by 2, a 7 by 1, a 1 by 4, etc., etc., etc. But when we write them together, that's the power. Now, the order of the matrices, as I say here, tell us if they can be multiplied. Why? Because when we write them side by side, if the middle 2 numbers are the same, then we can actually multiply these together. Ka-ching, that's it. So when it asks later on in the question, are the following matrices defined? They're asking really to say, can you multiply them together? And that's what I say here. And again, these are all downloadable. The notes are all downloadable. You can go into your summary book. So if I look here, I've got a 2 by 2, for example, and a 1 by 2. Can they multiply together? Are these two numbers here the same? No. So in which case, that cannot be multiplied together. But if I had a 2 by 2 multiplied by a 2 by 1, then actually let's just check, are the middle two values together the same? Yes, they are. And so actually that there can be multiplied together. Ka-ching, awesome. And actually the great thing here is that when the middle two numbers are the same, then we'll get the result. We'll know how big the matrix result is. So after we've multiplied them, we know how big the matrix is going to be because it's actually the outside numbers. So in that situation there, I know that my resulting matrix will be a 2 by 1. So what's that? That's 2 rows by 1 column. So there we go. It will have 2 numbers in it. So this is massive and it's used throughout the rest of the course. Now I'm just going to recap one other thing, and that's the element of an address, or the address of each element. So if we had this big matrix C here, this here has an address of C11. It means it's in the first row, first column. Yeah. What about this matrix here? That's going to be C12. First row, second column. Likewise, if we continue around, we've got this example here is 2-1. And this one here is 2-3. Now, the reason this is important is because these numbers here tell me when I multiply which row of one matrix and which column of the other matrix to multiply together. So, for example, that 1-1 means for my first matrix, first row, first column. This one here, first row, second column. This one here, second row, first column, and so it goes on. Now again, I'm going to explain what that means now with an example. So here is an example of some multiplication. And if you can get this sorted, job done. But again, remember, you can also use your calculator a little bit later on. So let's have a look. We've got 7, 4, 5, 6, and we've got 20 and 30. All right. So the first thing we have to do is see if it's defined. Is this multiplication defined? Is it even going to give me an answer? Because if it's not going to give me an answer, there's no point me wasting my energy doing it. So again, we would write here it's a 2 by 2, and that is a 2 by 1. Are the middle values the same? They are. So in which case, I now can write or draw out my matrix, because we know that my solution is going to be a 2 by 1. All right, so 2 rows by 1 column. Now what I'm going to do is write in a different color the addresses. So that's 1-1 and that's 2-1. Now you wouldn't do this. I'm just writing that for the moment to give us a bit of a hint. And let's come up with a different color. Let's try green. So what does that mean? That 1-1 here tells me take the first row of take the first row of the matrix, first matrix, and multiply it by the first column of the second matrix. Right, so let's do that. So what we're going to do now is we're going to do this row here times that column there. Now when you multiply matrices, what you do is you pair up the numbers. So the first number in the row and the first number of the column go together, the second number of the row and the second number of the column go together. And by that I mean they multiply together. So we're going to do 7 times 20. So that one there is 7 times 20, and we add 4 times 30. So we're going to add 4 times 30. Well, 7 times 20 is 140. 4 times 30 is 120. Add those together, it gives me 260. So I now know that value there is 260. Ka-ching. What do we do now? Well, we're now going to go to our next element, and it says its address is 2-1. So on the second row times the first column. All right, so we're now going to do this second row, this 5-6 times my 20-30. And again, we pair up the numbers. That's the first number in the row, first number in the column, second number in the row, second number in the column. So we know that therefore this value here is going to be 5 times 20. We're going to add 6 times 30. Right, so 5 times 20 is 100, 6 times 30, 612 is 180. Add those together gives me 280. and 80. And believe it or not, that is my matrix multiplication done. Now, obviously, I'm going to do loads more examples, or as many as I can fit into the time I have in this video, but it's going to take practice to get this right. You're going to make mistakes, that's fine, don't worry about it. Practice makes perfect, I promise you. So let's look at this. Let's do it. For the following matrices, decide whether the matrix multiplication is defined. And you will notice that I do that every single time I do a question. Why? Because there's no point me doing the hard work if it's not going to give me an answer. All right? If it is defined, give the order of the answer matrix and then do the matrix multiplication. Okay. So let's do one at a time. And so we'll start off with this one here, which is AB. Right, so let's work out my orders of my matrices first. So the order of matrix A is a 3 by 2. So it's a 3 by 2. And B is a 2 by 1. So are the middle values the same? They are. So in which case we now know that the outcome is going to be a 3 by 1 matrix. So 3 rows, 1 column. Right, so it's defined. So I'm going to copy out my matrix so that I can make my life a bit easier. 5, 2, 4, 6, 1, 3. Multiplied by, what I've got here, 8 and 9. So that's going to give me a 3 by 1. And again, I'm going to write 1, 1, 2, 1, 3, 1. And again, I would advise you guys not to do that for any exam questions, because unfortunately they won't know what you're doing and you'll get it wrong. Right, so let's have a look. We got this. What is 1, 1? First row, first column. Let's highlight them. Thank you very much. First row, first column. And we pair the numbers together, the first number and the first number. So 5 times 8. And I've got to add on the second number on the row, second number on the column, which is going to be 2 times 9. So that's going to give me 5 8s are 40, 2 9s are 18. That's going to give me the number 58. Right, let's do the next one. Let's highlight. So what have we got? We've got the 4 and the 6 and the 8 and the 9. So the first number is the 4 and the 8. They pair together. So 4 times 8 plus, what have we got then? 6 times 9. 6 times 9. So 4 8s are 8, 16, 32. 6 9s are 54. Add those together, it gives me a grand number of 86. So there we go, got 86. And lo and behold, we're now going to do the next row and the column. The reason being, it tells me here the address is 3 1. So third row, first column. Pair up my numbers. 1 times 8. So we're going to get 1 times 8 plus 3 times 9. Which gives me 8 plus 9, 18, 27, which gives me 35. Ka-ching, and there we go. That is my finished matrix. Now, if you're wondering, do you have to write all of this stuff out? Nope, lots of people, once they get used to this, do all of that in their head. But again, it is open to mistakes. How can we do this on our calculator? I hear you scream. Did you scream that? No, okay. So the first thing I'm going to do is I'm going to open a calculator screen. And what I'm going to do is I'm going to define my matrices. So let's fire this up. What do I want? I want a matrix. So I'm going to hit that one first. And I want 3 rows by 2 columns. So moving my paperwork out of the way, let's go 3 by 2. And let's enter my number in, 5, 2, 4, 6, 1, and 3. Now all I'm doing there is just tabbing across and it puts the numbers in. And I want to actually store this and we'll call it matrix A. And notice how it's turned my capital A into a little a. Okay, whatever. And then this one here, I've actually got a nice one set out for that, so I can use that predefined size for me. So it's 8 and then 9, and I'm going to store that in B. And then what have I got? Do I have a nice horizontal one? Nope. So in that situation, I'm going to do a 1 by 3. Hit OK, and that's going to give me 2, 4, and 7. And let's store that, please, in C. And then we got, so we got a 3 by 1. Hit enter, and we've got 8, 6, and 5, I believe, and store that in D, if you'll be so kind. Right, so having stored those all into my calculator, now all I need to do is go AB. And if I go AB and hit enter, nothing happens. Why do you think nothing happens? Well, because I didn't put my times sign in. So if I do A times B, life is going to get a bit better. And there we go, 58, 86 and 35 are my correct answers. Right, let's look at the next one. BA, can we do BA? Now again, what's the first thing we have to do? Check the order. So B is a 2 by 1. And we have an A, which is a 3 by 2. Check the middle numbers. Are they the same? Nope. So in which case, this is not defined. And in fact, I can't go any further. End of, can't multiply it together. Let's just check and see whether the calculator agrees. If we now do B times A, and notice they've come up in bold on my calculator because it means it's got something in it stored in there. Error, dimension error. Click on OK. And it basically was just saying, yeah, no, you can't multiply those together because they don't have the same order. What about this one? CD. Oh, those are the days, CDs. So what have we got? We've got a 1 by 3. And here we've got a 3 by 1. Ka-ching. Are they the same? Yes, so it is defined. What is the size of my outcome going to be? It's going to be a 1 by 1. Interesting. So we can now draw these out. So let's see what we've got. We've got 2, 4, 7. Multiplied by 8, 6 and 5. It's equals, and it's going to come out with a 1 by 1, which has an address of 1, 1, which means take the first row, well there's only one row, and multiply by the first column, there's only one column. So first row times first column, which is going to give me, if we would be so kind, first number by the first number, which is 2 times 8. So 2 times 8. We're going to add on the second number by the second number, which is 4 times 6. And then we're going to add on the third number and the third number, which is 7 times 5, which is going to give me 16 plus 6, 12, 18, 24 plus 35. That's 40. That's going to give me 75. Again, let's fire up my calculator and let's just check. CD, if you will, please. C times D. Hit enter, and there we go. We get 75. Now, again, this is going to take practice, lots and lots of practice, but it becomes important. Now, matrix powers, which I think is the last part of this particular video, again, becomes massively important later. When we start getting onto communication matrices and dominance matrices and all these type of things, which I promise you is coming up, we need to be able to raise a matrix to a particular power. All right, so we know from basic maths, as I've said here, that 4 squared is the same as 4 times 4, which is 16. 4 cubed is 4 times 4 times 4, which is 16 times 4, which is 32, 64. I'm not going to go any higher than that because my brain will die. So this floating number here tells you how many times to write the base and multiply it together. Right? So there's 3 lots of the 4 there. So it's 4 times 4 times 4. Now again, mathematically, that does not mean 4 times 3. It means 4 times 4 times 4. Now the good news is we can actually do that with matrices. Now, matrices raised to the power of 2, we should be able to do by our hand, but it becomes really tedious for higher matrices. We would not be doing that in any way, shape or form. We'd be using our calculator. So if A equals that and B equals that, determine A squared. Now, like all good mathematicians, when you square a number, you multiply it by itself. So that's going to be A times A, and I'm going to write that out now as 3, 1, 4 minus 1. And what's A again? 3, 1, 4 minus 1. Now, I suppose you should check, can we actually multiply those together? Well, that's a 2 by 2, and that's a 2 by 2. Are my middle values the same? They are. So in which case my outside is going to be the order of my matrix. So in that situation, I'm going to get a 2 by 2. Now I'm not going to write down those little numbers anymore. I'm going to try and remember my addresses. And the first address, this one here, is 1, 1, which tells me to take my first row and multiply it by my first column. All right, so 3 times 3 is 9. 1 times 4 is 4. 9 plus 4 is 13, and I'm going to go straight and write down the number 13 here. So there's the number 13. Right, what is the address of that matrix there? It is 1, 2. Yeah, so I'm now going to do the first row times the second column. Well, I've already got the first row highlighted. I would now multiply it by my second column. So I'm going to do 3 times 1 plus 1 times minus 1. Well, 3 times 1 is 3. 1 times minus 1 is minus 1. 3 minus 1 is just going to give me 2. So there is my value of 2. What is my address here? It is 2, 1. So the second row, first column. So again, we now need to, let's come up with a different color. We're now going to do my second row times my first column. So just undoing that because the colors are becoming horrible. So that means I'm going to do 4 times 3 times minus 1 times 4. Well, 4 times 3 is 12. Minus 1 times 4 is minus 4. 12 minus 4 is going to give me 8. Again, I'm doing this in my head. If you need to write it all down, do so. Download these notes, print them out, write all over them. They are yours. And again, last one here is 2, 2. So the address of that is 2, 2. Second row, second column. So again, we've got the 4 times the 1 and minus 1 times minus 1. Well, 4 times 1 is 4. Minus 1 times minus 1 is 1. 4 plus 1 is going to give me the wonderful value of 5. And there we go. So a squared is hopefully 13285. How can we check? I know, my calculator. So let's bring up my square one. We've already got one there. So 3, 1, 4 and minus 1. Now the great thing is your calculator knows how to do powers. So if you hit the power key, which is the up arrow here, and hit 2 and hit enter, out comes 13, 2, 8 and 5. Ka-ching! It can do it all for you. Now what about AB squared? Whew, have I got room to be able to do this? Well, let's see what we can come up with. So AB squared. Now and this is the important one here, is you've got to do b squared. All right, that 2 only belongs to the b. So in this situation here, that's a times b times b. Whew. Well, actually, I'm not going to do that by pencil and paper because that would blow out the length of this video. You could do it if you wanted to. And I would probably do b times b first and then pre-multiply by a. But in this situation, let's just do it on my CAS calculator because it's getting complicated otherwise. So what do we want? We want a. Well, I've already got an a there. So I'm going to copy this down. And I'm going to times, don't forget that times sign. Put in my matrix, 2 by 2, what's b? -2, -3, 3 and 5. And then we would have to square that. And that would give me, whew, he says writing in highlighter, what would they give me? -6, -11, -29, and -52. Now again, in that situation, it's important to note that that is a 2 by 2, that is a 2 by 2, and that is a 2 by 2. They are all absolutely multiplicable together. Oh, I said it was the end, it isn't. The identity matrix becomes really important again a little bit later on. So there is something called the identity matrix, a special matrix that is, basically, it has to be square. It only has 1s and 0s in it. The 1s are on the leading diagonal, right? And the leading diagonal is, I'll show you in a moment. The rest of these elements are all 0. So the most easy one to do, and probably the stupidest one, so a square matrix is actually a 1 by 1. Right, so that's a square matrix, it's a 1 by 1. What about a 2 by 2? Well, 1's on the leading diagonal. If you remember, the leading diagonal goes that way, and 0's for all other elements. Let's try a 3 by 3. 1's on the leading diagonal, 0's everywhere else. And I could do a 4 by 4, but we could continue. Now, it cannot be the other way. You can't have 1's going that way. You can't have anything with 1's anywhere else. It can only have 1's on the leading diagonal and 0's elsewhere. But what on earth is identity matrix used for? Well, let's see. Right, so first things first, we've got an example here. We're going to multiply them together. And in this situation, we're going to do a times I and then I times a. So we're going to multiply a and I together first. And that's interesting because I probably should make that an I. So let's change that to an I, which I'll update later on. And then find AI and IA. Right, so let's do that first. So AI, we've got 5, 2, 8, 3. multiplied by 1, 0, 0, 1 equals, are they defined? That's a 2 by 2. That's a 2 by 2. Are they defined? They absolutely are. And my order is going to be a 2 by 2. Rightio, we can do a 2 by 2. And here we go. Let's multiply them together. And if you remember, we're going to do this row by this column first. So 5 times 1 gives me 5. 2 times 0 is 0. All right, so I'm just going to get 5 there. So that's going to stay as a 5. Okay, next one. First row, second column. First row, second column. Okay, so 5 times 0, 0. 2 times 1 is 2. Add them together. That gives me a 2. Hold on a moment. All right, maybe different for the next one. All right, okay, we can do this. Second row, first column. 8 times 1 is 8. 3 times 0 is 0. Add those together, it's going to give me 8 again. Okay, maybe the last element changes. I don't know, we'll see. So that times that. So 8 times 0 is 0, and 3 times 1 is 3. Hold on a moment. I have just done all of that hard work to basically give me the same answer. So it would appear that multiplying by the identity matrix that way is like multiplying by 1. It's kept it the same. All right, it must be different the other way around. So let's do the identity matrix 1, 0, 0, 1 multiplied by 5, 2, 8, and 3. Again, well, I know that they are defined because they're 2 by 2s and 2 by 2s, and we can get 2 by 2 out. Right, I'm not going to waste any time here. Let's see what happens. That times that. So 1 times 5 is 5. 0 times 8 is 0. Add those two together. It's going to give me 5 again. Nah. This times this. We can do that one. So 1 times 2 is 2. 0 times 3 is 0 is 2. In fact, guys, believe it or not, if I continue doing this, it's going to give me the same. Now, although I started by saying that matrix multiplication isn't commutative, it is in this circumstance. So for the identity matrix, we can actually post-multiply it, which means that we are putting it after our matrix, or pre-multiply it. All right, so pre means before. And actually, when we multiply by the identity matrix, we get the same thing. And you're probably going to turn around and say, well, how is that important to me? What's the possible reason? Well, in previous videos, we've shown you how to add and subtract and multiply by a scalar, and this video to multiply by matrices. It is actually not possible to divide matrices. All right, so what we do is we use a bit of a trick with the identity matrix, but I don't want to rush ahead because that's going to come in another video. For now, though, that's the end of this video. Thank you very much for watching. Hopefully it has been helpful. Please subscribe on my YouTube channel if you can. Just let me know you're watching. Follow me on all those other social medias, and hopefully I'll see you in another video. If not, please take care and stay safe.